In this lesson, we're going to talk about the domain and range of a function. Now, I've given you the definitions on the page here, and for the most part, we're going to go through this lesson just using examples. So the domain is the set of values that can be used as an input for a function. Most often, this means x, right? Generally, x is the variable you're using as your input going into the function, and you're coming out with a value, right? So the domain is the set of x values, all right? So domain is the set of x values, and I'll give you an example here. Usually it's an element of real numbers, so any real number, and this is how we show it. So x is the element of real numbers. Now obviously this can appear in slightly different forms, but this is the form you're going to see me use. These squiggly brackets here, when we use those, that denotes a set. Okay, and that's why when I read it out loud, I'm saying it's the set of. Okay, that's what those brackets mean. It means a set of numbers of some kind. Okay, you know, x there is our variable. So x is the variable. And this symbol that looks kind of like a rounded E is a capital epsilon. Okay, and when you read that, you're saying it is the element of. And as I said when I was doing it, the R stands for real numbers. Okay. So similarly for the range. Range is a set of values that can be an output of a function. So generally speaking, this is what's coming out of the function. So it's f at x, or what we like to call it in our Cartesian plane is we usually use y. Okay, so we might write that as an example. Here we'll use range is a set of y values and I'm just going to erase that line because I did it by accident. Where y is the element of real numbers. So this is just a basic example here for domain and range. So if we put these together, this domain and this range, we could say we have a function that uses all possible x values and outputs all possible y values. So a common example of this would be a simple straight line, such as f at x equals x. Okay? This is a straight line that uses all real numbers in the domain and range. Okay, here I've got to quickly draw an example on a graph here. We're just going to write out the domain and range. I'm going to use the same colors that were representing the definitions on the other side, just so we can kind of keep track throughout our examples here. So we're going to start with domain. We're going to try to figure out the domain of this graph. So domain, again, remember, is the x values. And one way you can use to remember that is alphabetical. D comes before R in the alphabet. X comes before Y. So D goes with X, R goes with Y. That's how I remember it. So our domain here, we're looking at the possible set of x values. And it looks like this graph goes from here to here. And you'll notice that at the left side here, the -6, is an open circle, which means it doesn't include that value. Okay, so it's starting at -6 but not using the -6 value. So it'll use -5.99999 but not -6. And here you have a filled in circle, so it does include the 8. Okay, so that means that our domain here is going to be x values. And it's going to be x values that are between -6 but not include -6. And I'm running out of space here, so I'm going to go down another line. I normally wouldn't do that. Okay, to 8 on the other side, where x is an element of the real numbers. So that means x is anything that's real that falls between -6 and +8, but does not include -6. And now if you look at the range, it looks like our range goes from +6 down to -3, and it's pretty obvious that I hand drew this graph, so it's not perfect. So let's just say it includes +6 and -3. So we're going to write our range in a similar way. Okay, so our range here is the y values that are between -3 and +6, and it's all of the real numbers between those two numbers. Okay, here we've got another graph example, and here we're seeing a step graph, which means it's only using certain values. It's not doing a whole set of values. So let's start again with our domain here. I'm going to give myself enough space this time. So we've got our domain. We know that's the x value. So it looks like our x values are going from -9 all the way over to +10 here. And we're not actually going to include this one, right, because we've got that open circle, but we are going to include this end. And notice there's no actual breaks in between, because even though there's a circle here, there's a solid circle above it. So all the values in between those two endpoints are included. So our domain is going to include all of these values in here. So we know we're looking at x, and it's the x values such that -9 is less than or equal, sorry, it's just less than, not less than or equal, okay, just less than, x is less than or equal to +10, and it's all of the real numbers in that range. And then you're going to look at the range here, and it looks like we've got some integers that are being used. It doesn't have the numbers in between +3 and 0, all of them, just the integers. For instance, 2.5 you won't find as an output for this graph. It's only 0, 1, 2, and 3. So our range is going to look a little bit different. You're not necessarily going to see one of these this year, but I just wanted to show you that they're not always an element of the real number. So y such that 0 is less than or equal to y is less than or equal to 3, where y is an element of the integer set. So that I tells us that there are only going to be integers between 0 and 3. And we actually could write this another way as well. You could write, just because it's a really small set, so it's easy to do, you could write that we have the range here where y such that y is equal to 0, 1, 2, or 3. Okay, both ways work. One uses a few more symbols, but it's a nice small set, so you can do either one. Now what you're going to actually practice today is doing domain and range from a function, so given an actual function, so something like, we'll go with this as our first example, f at x equals x squared plus 4, and we have to use our knowledge to figure out what our domain and range are. So here we see, okay, this is a quadratic here. We're going to get a parabola as a result, and we can basically know by looking at it that x has no restrictions. We can put any value for x that you can think of, and you're going to come out with an answer. So that means that our domain is x is an element of the real. And then we have to figure out what our range is. So you're kind of have this in a nice form already. This is written in standard and vertex form at the same time. And we know we can use vertex form to figure out our range because that tells us where the vertex is. And we can also see that since the a value is a positive value that the parabola points upwards. Okay, and our vertex, we know the y value here is going to be 4, so if we're upwards, it's going to be all the numbers that are greater than 4. So that means the range is y such that y is greater than or equal to 4, where y is an element of the real numbers. Let's do one more example. We'll do one that maybe has a restriction. How about f at x equals 1 over x? Okay, And we have to figure out the domain and range here. So are there any values of x that you can think of to go in here that you wouldn't actually be able to do? So 1 divided by a number. Is there anything that we can't divide 1 by? Well, the first thing that comes to mind for me is 0. I can't do 1 divided by 0. You put it in your calculator and you'll get an error. Right? It won't give you an answer. It's an undefined number, 1 divided by 0. So I think that everything else will work, which means that our domain is x such that x does not equal 0, where x is an element of the real number. So that tells you it's everything except for 0 in the real number line. And our range, what values do we get out of this? So if we have a negative number, we put a negative number in here. We know we're going to get a negative answer, right? 1 divided by a negative number is a negative answer. And we also know that if x is less than negative 1, then f at x is going to be in the negatives and between, and be greater than 1, right? If s is less than negative 1. So you're going to get, let's say we'll use negative 0.5 as an example. So 1 divided by negative 0.5 gives us negative 2, right? So those numbers will be larger than 1. So f at x is going to be now greater than negative 1. Okay, so we know we're going to have this range here. And if we use negative 1 itself, then we would get negative 1. So we can actually say if x is less than negative 1, then f at x is greater than or equal to negative 1. What if it is, let's say, what if it is greater than or equal to 1? Well, then we're putting in larger positive values. Okay, so we're going greater than or equal to positive 1. So that means that when you're putting in values that get larger and larger into f at x, you're going to get results that are smaller and smaller, getting closer and closer to 0. Okay, so we're going to get f at x values that are actually going to be between 0 and 1. Okay, and we can look at each of these for the, again, we'll have to do x values that are between, that are greater than negative 1 but less than 0. Okay, we have to look at all those things, but you can kind of see a pattern here. We're going to get things in scenarios that are on opposite sides of the ones, but we're never going to get to that 0 point. There is no number to put in for x that gives us a result of 0. So again, it looks like our range is going to have a y value of everything except for 0. All right, and now you'll have to try some on your own.